Hello guys, so today I'm going to explain you all how can we solve this problem. This problem is known as number of ways to wear different hats to each other, and this is from 25th bi-weekly contest on Leetcode. The problem statement says that there are n number of people and exactly 40 types of hats which are labeled from 1 to 40, and what we are going to do is basically we need to return the number of ways that these n people can wear different hats to each other, and there is an array given to us which is hats of which is called hats, and each element within hats of I, this is basically 2D array where you can see. So this 3 comma 4 represents that the first person likes 3 comma 4 3 and 4 hat id 3 and hat id 4. Similarly, the second person likes hats 4 and 5, and third person likes 5. So basically what we need to do is how many ways they can wear their preferred hats, and one hat can be wear only one person at a time. So we need to find the number, this answer, and because it can be too large, so we need to return 10 raised to power modulo 10 raised to power 9 plus 7. So as you can see here, for this particular example there is only one way that this distribution can happen, because the first person chooses hat 3, and if he chooses hat 4, then second person has to choose hat 5 because 4 is already occupied. Then once he chooses 5, there is no other hat remaining for this particular person. Similarly we can see that I mean, yeah, because of that we can say that he has to, the first person has to choose 3, similarly the second person has to choose 4, and this one has no other choice than 5. So let's take this example. For now we can say that we have certain n number of people which can be as max as 10, and we have exactly 40 types of hats. So these boxes represents hats, and each of them are labeled with some number from 1 to 40. So the biggest thing that we have here is that each hat can be used by only one person. All right, so there can be multiple ways to distribute so that each of them gets one of their preferred hats, and in each of them it can never happen that one hat is shared by two or more person. So with this hint, what we are going to do, we know that one there can be a case that a particular hat is not preferred by anyone. So for example, if you see this one here, we have 1 to 40, but only 1 3 5 are the ones which are preferred by our number of persons that we have here, and rest of them are not preferred by anyone. So there can be such hats. For example, let's say 6, which does not have any preferred list, so it has count 0. So or you can say the list here would be empty. All right, but there could be some who prefers more, like there can be some hat which is preferred by 1 2 3. I mean, these are the IDs of the people which can actually go from 1 to 10 only. So 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 yeah, based on this idea, what are we going to do? We are going to recursively check for all these hats starting from 1 to 40, and what we can do, we can just check whether this hat has some preferred, whether this particular hat is preferred by at least one person or not. And if it is preferred, we have a choice to either give it to one of the person, or we can just not take this one, because there can be a case that this person has let's say one person has list of all these, I mean he prefers all of these hats, and in one of the configuration we don't consider that hat at all, right? So to catch this particular case, what we can also think in a way that one particular hat can possibly not be given to any person, and if it has, if it has any list of preferred person at all, and otherwise we can try to give it to each person one by one. Like if for example, let's say hat id 2 is preferred by 1, 2 and 3, I mean these people 1, 2, 3, then we can try to give it to this person 1 and then recursively try to solve this for the next hats onwards. But when we are going to give this person this id to, I mean this hat to this person with id 1, we need to keep track of one more thing, and that particular thing is very interesting. So basically, uh, it can happen that some hats ahead of this hat id 2, let's say for example this hat id 5 itself is again preferred by this guy 1, all right, and it is preferred by some other id 5 for 1, 4 and 5 as well, like one from 1 to n, we can say n is greater than n equals to 10 for now. So, let's say for example we have given this hat to id person with id 1, then we need to know with that we need to mark some way, I mean we need to somehow mark that for the future hats it is obvious that this person is already wearing a hat and we should not consider even if it is in the preferred list for this particular hat. So basically once we see that this hat can again will have, I mean this hat will again have two choices, whether it can be given to one of these person or it can be left. So we can recursively solve for the left one. Then when we are going to iterate over the person here, then what are we going to do? We are also going to check whether this person is already wearing a hat or not. All right, now let's talk about how are we going to keep track of this particular thing. So what we can observe here is the number of people we have is 10, all right. So this is something which encourages us to use mask, I mean that means bit masking technique. So if you're not aware of bit masking technique, I would suggest you to first read about it. I will definitely try to make a separate video there on bit masking, how bit masking helps us keep track of similar situation for the shorter constraints. As you can see here, n is only 10. So basically think in terms of number of bits we have. So I mean each person is represent I mean the status of each person can be shown by some bits. So because we have 10 person here, so we can have at max 10 bits. So 0 represents that none of them are wearing hat currently, and if we say, I mean this is 0 0 0 0 up till 10, I mean whatever the number of people that we have here, so it will be equal to 0. Similarly there can be some situation where we'll have 0 0 0 0 0 and then 1. This represents that the id with 0, I mean the id at the person with the first or you can say, we can always say this is 0, this is 1, this is 2 here. So this first bit is, I mean the first most the rightmost bit is on here, that tells us that this first person is wearing a hat. And now whenever we are going to distribute a hat, we can simply check in this mask, we call it mask, that this particular bit is set or not. If it is set, then we will not include it. So it can be represented by 1 in decimal form. And similarly we can say for other for let's say for example 3. So not 3, for example we have something like this. So all these bits are 0 except the last 2. This represents thus the first and second person only are wearing hat and rest of them are not wearing, and this is represented by 3. All right, so if only second person if we have to represent a situation where only second person had was wearing a hat, then this would be represented by all of them would be 0 and then it will be 1 0. All right, so 1 0 represents that only the second person is wearing a hat. Similarly if only third person is wearing hat, this would be represented by 1 0 0. All right, so and this in decimal form it is 8. So what you can see here is this can be as big as all of them are wearing a hat, and that would be our base case. That means if all of them are represented by 1, and as you can see here, this can be as big as 2 raised to the power 10 minus 1, because n here is 10. This means this can be as big as only 1 0 2 3. So this is not big, and that's why we can use this mask, so that each mask represent a status of which person is wearing a hat or not. And I'll show in a moment that how quickly we can check whether this person is actually, how can we show whether this person was already included in the mask or not, and if not, how can we quickly make sure that this is going to be masked for the further recursive calls here. So yeah, this is what the basic technique is. Basic idea behind this approach is, so what are we going to have? We said that we are going to try out for each hat one by one. So let's say we have our recursive function f, I will call it. So at any moment we have some recursive, we have id of hat, right? And then we also, as we just discussed, we also would need some mask. All right, so this mask represents how many which are all the person are already wearing a mask, and this id is the hat id that we are currently considering. So at any moment, what option we have is we can just skip this particular hat, regardless of whether this hat is preferred by any person or not. So we can just move to the next hat, and we can, because we haven't changed anything, I mean we didn't give this hat to anybody, so the mask will remain same. Or what we can do is this is one way we can distribute this hat to any of the person. Or what we can do, we can try for all these people. Let's call this array a, or let's call this array. All right, so what we can do, we can try out all the elements of this array. Let's call it x on this array. And what are we going to do? We are going to check whether this x is already in the mask or not. So once I'll walk through the code, I'll explain how can we check quickly. So what I'm gonna write here is if x is already included or not. Right, so if it is already included, we can just x is included, we can just skip including this one and continue. All right, otherwise what we can do, we can make sure that this gets included, and then we can call our function f for the next id of hat, and just call this with the new mask. And what will be the new mask? New mask will be the mask where it has represented the state that this person is also included. So let me just call it n underscore mask. Right, and this is another way we would be getting. So all of this would be added, I mean we can just say that this is our answer. So this will be f plus, and this recursively added answer for all of these values, values in this array. All right, and we need to just keep track of all the we need to keep track of the overflow, and because we have been suggested that this answer can be very large, so we need to keep track of the overflow and keep taking the modulus after each calculation. I'll explain you in a moment in the code how can we keep track of that. So yeah, let me explain you the code now. And what are we given? We were given this number of ways method, and we were also given a vector of vectors. The format was something like this, that the first element represents an array. That means all the hats which were preferred by the first person. Then the second element is the list of hats preferred by second person. But as we discussed here, what we want is the other way around. What we want is a list of person who prefers each particular hat. So what I've done here is I've just created a map of id and this vector of integer which tells you the so basically what I want to do is, basically I want to map each id of hat with a list of person who prefers this particular hat. So I have just traversed through that. given array, given hats list, and I have built this map of vectors, like the format that we want to have in. And then what I am going to do is, as I said, I'm going to start with, as you can see, what I have done here is basically h minus 1, just to keep everything zero based indexing. Keep everything in zero based indexing. So yeah, so if this is 3 comma 4, that means what I'm doing is I am just telling that hat 2 is preferred by the guy with index 0, and also hat 3 is also preferred by the guy with index 0. So I'm just trying to explain this very well so that we don't get confused here with the zero based indexing. And as I explained, so this is our recursive function where I am doing all the magic. So I as I said here, our base condition which we discuss here would be the case when all of this number of people that we have already got one hat or wearing one hat, and which can be checked by comparing this whether mask is the status of how many people are already wearing a hat or not. So if this is equals to 2 raised to power n minus 1, that means all of these bits are set, and this is equivalent to 2 raised to power n minus 1. So for example, for n equals to 10, it is 2 raised to power 10 minus 1. So if this is the case, that means we have reached a valid situation and we should return 1. And if we have reached all our, if we have exhausted all our hats, and if the situation wasn't if this wasn't caught already, that means this status is not true, and we have reached all, we have exhausted all of our hats, and there are still some people left without any hats, so this is not a valid situation, so we should return 0. And you can try on yourself and find out that there can be overlapping subproblems. So what we have also done is we have memoized this state, that if this particular state is already seen, then we should return the calculated value, which I am also storing in case if it is not already calculated here. So as I said, each hat has an option whether it can be left without having given it to anybody. So what I've done is I've just moved to the next hat, and with the same state of mask. And what else we can do, we can try to give it to the person's preferred one of the person who prefers it. So for example, so what our array of I, so basically this array of idx it would be a list of the person who prefers this. So I'm just traversing over each of this for each of this value, and just trying to find out. So let's say for example this is j, so j represents a person id who prefers this idx hat. All right, so now what we are going to check is if this person is already wearing a hat or not. So mask, and this is bitwise, and one left shift j is representing 2 raised to power j. That means what we are going to do is we are going to check whether this person, for example, when we said that we want to see whether third person is wearing a hat or not, so what we can check is we can just check the third bit from right, and if it is set in our mask, then we can be sure that this is wearing this person is wearing a hat already. And how we can do that, we can just simply say, we can just make a bitwise AND as we are doing here, and bitwise AND would take care of finding out whether this person is wearing a hat or not, or you can say whether this particular bit is set or not. So if this person is already wearing this hat, then we should continue. Otherwise we can just as I said, we can just create a new mask, and new mask represents the new status of this mask. And yep, And if this particular thing like the bitwise and bitwise or is bit confusing for you, I'll try to share some resources in the description below where you can try to understand how these two things works here. But this is fairly simple, and I will leave this as an exercise for the viewers to figure it out. Then yeah, the rest of the things is simply simple recursion, where I'm just trying to add answers for each of these case. So either this recursion will give me either 1 or 0, and if it is 1, that means we have find a valid way, right? And as I said that we need to also keep track of the overflow happening here. So here we are just taking modulus to the our answer in every recursive step, and in the end I'm memoizing it. So yeah, the rest of the things is pretty straightforward. So I hope I was able to explain you guys. There's just one note that I wanted to share with you people, that the similar problem is also was also given in this Codechef August 14 challenge, long challenge. And at that time I was just trying to learn competitive programming. I couldn't even attempt this problem. This problem is exactly this problem is very much similar to what we just what we just see actually saw here. And the only difference here is that instead of hats we have 100 we have instead of 40 hats we have 100 different t-shirts, and instead of person we have little elephants. So the rest of things is very much similar. You might find some problems taking the input here, but I'll share my code here, you can understand. And then when I solved this problem, I went ahead and tried to solve this one again, and I was able to solve this. So after 6 years I was able to solve this. I don't know why it doesn't show here. No recent extent, no recent activity. Yeah, I can show that this. Oh, because I was coming from the challenge link. So yeah, you can see that I was able to solve it today. So yeah, I would recommend everyone to keep practicing hard. You will definitely try you will definitely learn new things and would be able to come back and solve things later on. So yeah, I hope I was able to explain you guys, and if there is anything that you want to discuss with me or comment or any feedback for me, please leave that in the comment section below. Please check out my channel for the bunch of other similar videos, and yeah, hit the subscribe button if you haven't already. Thanks for watching this.